philosophy has 4 different points. I clearly mentioned instruction, register, pipelining, and load and store architecture. These 4 important points with clear explanation you need about this design philosophy, risk design philosophy. You also know that ARM design philosophy is also a risk design philosophy along with extra features. You need to clearly write what ARM design philosophy has in addition to risk philosophy. So clear from what is microprocessor architecture, different architecture definitions, what is ARM7 TDMI, what features. If I ask you, can you write the ARM7 TDMI features, then immediately you should recall in your mind ARM7 TDMI is one of the microcontroller. What are its specifications? If I ask, take an examples of LPC2148. I have clearly given the specifications of LPC2148. LPC2148 is a 32-bit. What is ROM size? What is RAM size? How many timers it has? How many ADCs it has? How many DACs it has? How many watchdog timers it has? Those are all called specifications of LPC2148, which is an ARM microcontroller, which is ARM7 TDMI example. So now ARM design philosophy, what it should have, all the features along with risk design philosophy, it should have extra features. I clearly mentioned those features. You should not run away from those features. Recall. Now, what is embedded hardware and embedded software? The thing which supports the hardware, supports the software is a embedded hardware. And I clearly said what all things falls under this. Embedded hardware means a general hardware, what it has, all the block, all functional blocks connected by data buses, address buses, and control buses. That's it. So what embedded hardware has, different things it has, I clearly mentioned. Basically, it has ARM processor along with some controllers like memory controller, interrupt controller, and it also has additional IO devices like timers, okay, timers, ADCs, DSCs, extra devices or Ethernet, extra devices which can also be incorporated on a single chip. So ARM embedded hardware is that. Along with that, the external devices, and how these external devices are connected by bus architecture. So okay, ARM embedded hardware has ARM means advanced microcontroller bus architecture, AMBA. Advanced microcontroller bus architecture it has. It has a bus architecture. It means all the devices are connected by buses. That's it. So some software which should run on this hardware. How they run on this hardware? Always I should say that software first lies on the main memory. Then from the main memory it is accessed. It goes to registers. From registers it is connected to different blocks, functional blocks like ALU, different functional blocks. I don't want to name them. So if you see ALU as an example, which takes the instructions from the memory through the registers, let's say, comes to the ALU. ALU performs the addition or operation or logical operations accordingly. Then it means that this is a simply the software. What are the different softwares we have? We have initialization software. What is the initialization software? Initialization software is the software the processor or the complete hardware is turned on. It means when the power plug is put on, it means that immediately the processor turns. When turns on means which we call it as booting process. That is called as bootable code or initialization code. What it does, it first sets up all the memory, minimum memory requirement to be connected to the processor first. The processor is turned on, memory is get connected to the processor. That's the first initialization work, which is nothing but booting process or restart process, what we call it as. Boot software. Then after booting software, it may enter into any of the modes. That's what very important. What is that? Now the processor can go to any of the mode. There are different modes in the processor. The processor may go to an operating system mode. It means that system mode I'll call it. So once it enters the operating system means operating system is again a software. So the processor goes according to the operating system software. That's it. So it means processor listens to the program called as operating system. So operating system which takes care of all the operations associated with the processor. That is what we're doing. Other than that, related software is there. interpolated softwares are there, so many other softwares that forms the embedded software for a particular application. We are not going to our head for the biggest application of an embedded system. Embedded system means it has hardware, embedded software. Embedded hardware means hardware with ARM processor along with external peripheral device which are connected. Embedded software means the complete software which makes all the tasks feasible in your embedded system. So this rough diagram what I have shown a clearly simple operation of a microprocessor or microcontroller or any uh, microcomputer you can say. What is the simple operation? The entire process is called as a program, which is nothing but collection of instruction. It means that instruction set is clearly defined for a processor. Any processor you take, either microprocessor, microcontroller, or any type of processor if you take, instruction sets are defined for that particular processor. Collection of those instruction set in the particular memory is called as a program. Now instruction is fetched one by one, given to the registers which are there in the processor. Let's assume from the register it may go to different blocks. Let's one block as ALU. It goes to ALU. ALU does certain operation, and the result is again passed back to the register or directly to the memory. So all these things will happen with the processor with the help of instruction only. It means that the processor executes the instruction. Executes the instruction. What is instruction? An instruction is command given to the processor. That's it. So instruction, selection of instructions will achieve a particular task. So the meaning is very simple. Every processor is associated with fetch operation. It means that getting the instruction. Decode operation. It means that converting a particular instruction data to the machine code so that machine can understand. Then execute. Execute means depending on what type of instruction the processor understands this operation has to be performed by that particular block. That particular block executes, it means performs that operation, and it stores the result back into the registers, or from the registers it may go to the memory. So results are usually stored in registers or memory. That is the beauty of all the processors. It means that processor is not alone. What is a processor? Which we are going to discuss now is ARM processor, how really it works, what are the different functional blocks has to quickly and understand the flow. Deepika, am I audible?
Yes, sir.
Okay. Yeah, my screen is visible.
Yes, sir.
Sir,
Yes. Tell me. Something you have said? Deepika.
No, sir.
Okay. So what is the screen visible to you?
processor
ARM
fundamentals.
Yeah.
processor fundamentals.
Okay. So now let us understand this now. So what I'm trying to say is now once I understood overall working principle of any processor, now let's look into our processor and what are all the things we need to study thoroughly. What we need to study is as follows. We need to study first the ARM fundamentals, then we'll enter into the more details about the ARM processor. ARM fundamentals itself is the first unit, and in the instruction set, and the third unit programming with ARM processor lies in. ARM processor fundamentals includes, as I said, registers and important register which is called as current program register. So please understand, registers are most important part of ARM processor. So what I said, I clearly said that whenever you are explaining working principle of any processor, you understand that the data or the instruction which is fetched from the memory, that is the first thing. Then decoding has to happen. Then the execution has to happen. To do all these three, fetching from the memory is done. Where the data will be taken? The data will be taken into registers. That's the beauty of all the processors. So all the processor definitely will have set of registers. Registers are a temporary storage devices. You can call it as temporary storage devices. And registers are used for performing various operations. Registers are also used for performing various operations. It means that most of the instructions are associated with the registers in certain microcontrollers. ARM processor is also one among them. It means almost all the operations are associated with registers. Please remember, almost all the instructions will make use of registers. Please understand my statement. They will make use of registers. It means that every processor has their own instructions. ARM processor also has their own instructions called as instruction set. These instructions make use of registers. How they will make use of register, we'll see. How many registers are there also we will see. One special register which we will look into, special purpose register you can call it as. Registers usually classified as general purpose registers and special purpose register. There are two important special purpose registers called as current program status register. Another is saved program status register. Saved program status register, how it is useful and what are the requirements we will see. But most important part of the ARM processor is register, and that too current program status register is important. You should thoroughly know about the current program status register, which is generally called as CPSR. CPSR is very important, current program status register. Why? Because current program status register is associated with the terms called as processor modes. It means what are the different modes the processor can operate? What are the different modes processor can operate? What is the meaning of this? Meaning is the processor fetches, decodes, executes, we will say. That is common operation of a processor. But while doing this, processor, how many registers it will use? Whether it will use all the registers, which mode it is called as. Whether it will uses a few register, which mode it is called as. If it uses only two registers, why it uses two register? What is the purpose? Why we should be in that way to access only few registers? These are called as different modes the processor can operate. Please understand, processor makes use of registers according to the requirement. And by the requirement, we will name them as different modes of operation. Processor can be in this mode when I say it uses these registers for this purpose. Processor can be in this mode. It uses these registers for this purpose. The processor can access this register. The processor can change the value in this register. It means that if I am in that mode, then only I can change. That is what the processor says. That's what the processor mode. There are various processor modes which are defined by which register? By current program status register. It means that all the registers in ARM processor are 32-bit registers. So each register, if you take, it is having 32 bits. Each bit in that register has the clear meaning that we need to understand. Especially the special purpose register are very much important for ARM processor. ARM processor, while doing its operation, it looks into the current program status register, not the other register. That's what the current program status register is important. Why it looks into the current program status register, if you ask me, I will say this much only now, that the current program status register, it is required for controlling the internal operation of processor. It means the entire control and the internal operations. Control and internal operations can be done by setting the values in the current program status register. It means that how many bits are there in current program status register? If you ask 32, those 32-bit values plays a very important role. How we can divide that program status register to bit register so that I can call it as the processor is in this mode. And if I set certain values, then I'll say that these are bank registers. The sum of the field values, if I change, I will say that these many bank registers are there. Then I'll say something like this, some value I will change in the current program status register. I'll say that it is in this particular state. And I can also say that by setting one bit, I'll say that it is using ARM instruction set. By setting that bit as 0, I'll say that it is using thumb instruction set. I can also say that if I set certain field values as 1 and 0, I'll say that I'm using interrupt masks. What are those interrupt masks? It means at setting a value to 0 or 1 in those fields of the current program status register will make me the processor to work in these situations. What are those situations? It may be different processor modes. It can be different band registers. It can be using instruction set. It can be using the particular interface. Or it is the most important point called conditional flags. It means that certain fields in the current program status register talks about the conditional flags and conditional execution also certain fields. So overall to say, current program status register is the total register which takes care of control and internal operation of the ARM processor. ARM processor control and internal operation is totally depends on the current program status register values. So what value you set inside the current program status register, that itself. So who will set this value? How we will set this value? That comes in your program. That's how we go. Pipeline. Pipeline is nothing but how it offers the execution of set of instructions simultaneously. That's a simple explanation, pipeline, which falls under ARM processor. Then we look into the core extensions. The extension for this particular process has been done to achieve some additional task that falls under this. Then we will say by changing the various instruction set, we can say architecture revisions can happen. Different architecture revisions by varying sort of changes inside the instruction set leads to the architecture revision. So based on these instruction set variations, slight variations and slight functionality variations leads to different architecture revisions. Then we can name them as ARM processor families. Means one of exactly how set of functional blocks are connected, how working principle is there. That family I came to know. If I came to know ARM 7 family, then similar small changes leads to ARM 11 family. Then extra advanced concept if I add leads to ARM Cortex M3 family, ARM Cortex M4. So those we'll look into details. It means we'll understand the concepts in details. So let's now go ahead. Let us start with ARM core. Okay. Pramod, am I audible?
Yes, sir.
Yeah. So now if you see the ARM core processor, it's very, very simple. Quickly understand how you are going to draw the block diagram. This is the block diagram you are going to write in your exam and you are going to explain. How exactly it happens? Very simple. Outside world is not visible to us with this block diagram, you can say. So ARM core processor is nothing but connection of these functional blocks which are shown in the block diagram with the lines called as data buses. Very simple. What is that? The ARM core processor is nothing but the connection of all these functional blocks with the data buses which are shown by lines. All these functional blocks are connected by data buses shown by lines, and the direction of those lines shows the flow of data. Please understand, the direction of that line shows the flow of data. So all these lines are data buses which are connected in such a way that all function blocks are connected, which forms the ARM core or ARM processor block diagram. Now what is the working principle? You can observe one important point. The data is coming in. From where the data is coming in, I clearly told that whenever the data is coming in, it means that it is coming from the memory. As I said, the program is stored in the memory. Program is nothing but collection of instructions. So instruction by instruction, the fetching operation is done. When the processor immediately turns on, it goes into the fetch operation first. The memory, from the memory, the data is fetched. Once the data is fetched, that's what the incoming line which is shown, data, the word. So now what is the data? The data may be the instruction or it may be the data itself. Please remember, instruction means, let's say, an operation called as add, ADD, add is an instruction. MOV, move is an instruction. Okay, so LSR, left shift right, is an instruction. So it means that instructions are English like words. Okay, English like words which tells some operation to the processor. Those instructions are stored in the memory as the data. That once that data is fetched, that data directly goes to the instruction decoder as shown in the diagram. Instruction decoder converts that add instruction or LSR instruction, whatever the instruction comes, into machine code. Please remember machine code. Now the machine code of that instruction is called as opcode. Remember what you mean by opcode if somebody asks. So any instruction can be associated with an operation called as add. An example, add 05. If I say add 05 means what? Add 05 means indirectly it says that, or you can say like this, add R1 comma 05. If I say like this, add R1 comma 05, R1 is the register, 05 is the direct data, add is the instruction, mnemonic. So the instruction should be converted into hexadecimal number or machine code by the instruction decoder. Once the instruction decoder is done, that is called as, whatever the data converted is called as opcode. What is the data which is 05 should be added to the register? That 05 is called as operand. So instruction has opcode and operand. Why it has opcode and operand? Because instruction decoder converted into opcode, and operand is nothing but the direct number which is an hexadecimal number, 05, let's say. So both instruction and data are represented as data only. That data comes to the sign extent block. What is the sign extent block in the ARM core? It checks for, because since it is a 32-bit microcontroller, it checks whether the data coming is signed data or unsigned data. If conversion is required, it does the conversion and convert it into 32-bit signed or unsigned data. Any 8-bit data or 16-bit data is coming, because we know that the memory which is connected may be a 8-bit memory, 16-bit memory, or 32-bit memory. The data which is coming should be up converted to 32-bit. That's what the sign extent is used. Sign extent, both it takes care of sign as well as unsigned representation. So signed 32-bit or unsigned 32-bit data which is coming out of the sign extent. Sign extent converts into 32-bit signed or unsigned data. Now very important, what is that? ARM core has registers, which is the most important point. Okay, the heart of the ARM processor is the registers only. What are the registers we have? It is visible here, which is called as register file. It is named as register file. Sometimes they call it as bank of registers, or sometimes they call it as register bank. So register file has the set of registers R0 to R15. You just observe, R0 to R15 are the registers available. Now when I say R0 to R15, these are called as general purpose registers, R0 to R15. Please remember, this is the register file. In R0 to R15, R0 to R12 are called as general purpose registers. Please listen to the words carefully. R0 to R12 are called as general purpose registers. R13, R14 and R15 are called as special purpose registers. R0 to R12 are called as general purpose registers, which can be used for any general purpose application as the ARM needs. It makes use of those registers. R13, R14, R15 are called as special purpose registers. Okay, R13, R14, R15 are most important, called as special purpose register. R13 is called as stack pointer. See the other name, R13 is called as stack pointer. R14 is called as link register. We'll come to that. Okay, then R pointer are the special names for the registers R13, R14, R15. So R13, R14, R15, they not only act as general purpose, sometimes also most important point of them is they are special purpose registers. Now, very interesting point. We have these register files. The data which is instruction or the data which is comes gets into the registers and stored in the register. Now what next? The most important point you can observe the two lines coming out of the register file called as A and B. A and B are the two buses in the ARM core. One A is named with Rn, another name is Rm. Rn and Rm are called as source registers of the instruction. Please understand. It means that ARM core works with the help of ARM instruction set only. These instruction sets, as I said, makes use almost all instructions makes use of registers only. For example, if I say add R1 comma R2 comma R3, please understand, if I write an instruction add R1 comma R2 comma R3, if I write, the meaning is very simple. First, R1 and R2 are called as source register, R3 is called as destination register. Point should be very clear. Here Rn, Rm and Rd, you can see the three names. These are the general names given. Rn and Rm are called as source registers. Rd is called as destination register. Take an example. Add R1 comma R2 comma R3. If I write instruction add is associated with the registers R1, R2 and R3. Where they are present in the register file only R1, R2, R3. I am giving the general name as Rn, Rm, Rd. How the general instruction can be written? Add Rn, comma, Rm, comma, Rd. So the meaning is R1 here is Rn, R2 here is Rm, and R3 here is Rd. Very simple. So Rn and Rm can take any of the registers like R0, R1, R2, R3 up to R15. Rd can also take any of the registers from R0 to R15. One thing should be ensured that one should be thing ensured that if you take the registers value, overwriting will definitely happen if you take twice. So that's what you should be careful while choosing the registers. If R1, R2 and R3 I have taken, then I'll choose that Rn and Rm are called as source registers, Rd is the destination. Operation is very simple. What is that? Rn and Rm are coming with the two buses A and B from the registers, because Rn and Rm are two registers, source registers, and those values are directly come to ALU. An addition operation, if it is there, add operation will be done. If logical operation is there, logical operation is done. There are hundreds of addition operations and logical operations, and combination of them will achieve some other tasks. So ALU does so many things. The output of the ALU, you can see it goes as RD. It goes as RD. RD means one of the register in register file only. So where the result goes and stores, that's it, because instruction has clearly the register names. Add R1 comma R2 comma R3 means R1 and R2 are source registers, those two are added and the results is stored in RD, that is R3. Similarly, the and back of that where multiply and accumulator. So there is an accumulator, one more register, the value which comes from A and B, that will be multiplied. The result in accumulator where you want to store. So MAC operation and ALU operations are two important operations, arithmetic logic unit and multiply and accumulate unit. These two unit performs the all arithmetic and logical operations easily. There is one more extra feature which is added is called as barrel shifter. It's a very important component which has been added. While taking the second source register, when I say the instruction add R1, R2, R3, instead of directly giving R2 to the ALU, okay, R2 here is nothing but RM, right? RM directly to ALU, RM is passed to barrel shifter, and certain manipulations can happen with, or shifting operations or many other operations happen with the barrel shifter. We will study thoroughly how the barrel shifter will help us to realize certain expressions. This barrel shifter output along with ALU together will address so many expressions easily. That's what ALU and barrel shifter will achieve complex expressions. Okay, realization of the complex expression whose output again stored back to the RD. RD is one of the register in the register file. That's it. Now, interesting point is ALU not only does that, the instructions are fetched, the process is continuously happening like this. At the same time, if any instruction comes in such a way that I need to write the data onto the memory back, please understand. We read the data from the memory and we did the operation on ALU and the data is stored in the register, that is fine. What is next? The ALU also helps one architecture of ARM processor called as load and store architecture, which is one of the part of the RISC architecture, which is ARM architecture. What is that? Load store. Load store instruction, when they come, it means that ALU puts the address of the data which has to be passed to memory. It means address register will hold the address of the memory with the help of ALU. Please remember, ALU helps by looking at the instruction. If you are passing an instruction called as load instruction and store instruction. Now, very important, I should not say load now. Load means a load instruction is an instruction which is used for fetching the data from the memory. Please remember, load is an instruction which is used for fetching the data from the memory. Data may be instruction or the data itself. Whereas store is the instruction which stores the result not only to the register. I wanted to store the result to the memory. Store is used to store the result to the memory. Store is specifically for that in the ARM processor. When store instruction comes, ALU immediately after its operation puts the address to the address register. Address to the address register. Then by looking into that address, okay, the data is written. See, right line is there. The data is written to the memory. Right line writes the data to the memory. This is how it happens. Simultaneously, one more point you observe, program counter is there, PC is there, left side you can say R15, and there is an option called as incrementer. Incrementer, every time it once it does called as store operation. This time it increments the address register so that the data which gets in stored in the consecutive memory location of the consecutive address of the memory location. So right line, you can see the direction, right line writes the data onto the memory. R15 is the register in the register file which is used as a PC. Please remember, it is a program counter which is pointing to the memory address, next memory address. PC always points to the next memory address. That is what is happening, because incrementer will take care of automatically program counter increments once it fetches the data from the memory. So this is the simple working principle of ARM core processor. So please remember, any complex sort of operation when they come, please understand they will be clearly solved by ALU, barrel shifter and MAC unit. The results are usually stored in the register. That's what, please remember, ARM processor makes less use of memory. If it wants to make use of external memory, it needs to have special instructions called as load and store instructions. So repeatedly load and store instruction if it uses, it means that it is consuming more cycles for execution. Then we cannot call it as a RISC processor. RISC processor has to consume less memory, less cycles to execute the instruction. Why it consumes less cycles? Because it is more operating with the register banks which are there in this block, and along with the functional blocks called as ALU, barrel shifter, and MAC. Any sort of operations can easily handle by combination of these blocks. Sometimes ALU barrel shifter works together. Alone handles certain jobs. Sometimes barrel shifter alone handles the job. Sometimes only ALU alone handles the job. Almost all the jobs will be done by this. That is the beauty of ARM core processor. This is the working principle that you need to explain. Now, when you
Sir,
look, yes,
sir, that accumulator, what does it do, sir?
accumulator stores the result. So accumulator is again a temporary register. Accumulator comes in an instruction, you will come to know something like this: add 15. If I say add 15 is an instruction where the term accumulator is not at all visible. So indirectly accumulator is present in the instruction. Add 15 means add the 15 to the accumulator and the result is stored in the accumulator. That accumulator temporary data is passed to the register for the storage. So accumulator, you take it as a temporary register or a quick register to fetch and store. You can access and store from an accumulator. Accumulator is a quick temporary storage device, or you can call it as a cache register. Okay, so we'll come to know as we discuss the instructions. So now I just said registers are very important part of your ARM processor. Now you tell me, what are the registers available? R0 to R12 called as?
General purpose register.
Perfect. R13, R14 to R15 shaped here, or I mean shaded here, are called as?
Special purpose register.
Excellent. Special purpose register. Then there are two more registers which are shown here: CPSR. SPSR is not shown, but both are there. CPSR and SPSR are called as? Subramanya? CPSR and SPSR are referred as?
Control program status register and save
Current
program
program status register, right?
Yes, current program status register and saved program status register. They are the program status register. It means the status of the complete program is with them only. So it is something like this. These are the key registers. If I change certain values in these registers, CPSR and SPSR, if I change certain values, the whole logic will change. Please understand. It means program modes, interrupts, exceptions, executions, conditional executions, conditional flags, everything is set inside these registers only. That's what each bit in CPSR and SPSR plays a very important role. In the next coming things, whenever we discuss instruction set and those registers, we'll always focus more on CPSR. Other registers are common, they are of 32-bit, but these two registers which are of 32-bit are very, very important. And three more registers which are listed above, as I mentioned: special purpose register, R13, R14, and R15. Sometimes R13 is called as stack pointer. It is pointing to the stack top. Stack top means it is a memory location where stack allocation is done. Always the system makes use of stack memory allocation. So R13 is the register in ARM controller always pointing to the stack top. R14 is link register which stores the return address. Link register which stores the return address, R14. R15 is a program counter which is always pointing to the instruction, next instruction which has to be fetched, pointing to the memory of the instruction which has to be fetched. Next instruction which has to be fetched, that address will be there in program counter. That's what you always remember. Stack pointer is pointing to stack, top of the memory location, stack memory location. L return address. For example, if program and someone and bring that code, I mean execute that code and again come back, if they say, This is called interrupt. Somebody interrupted me to go to some other memory location and execute set of code and again come back. So coming back is called as return address. Who will have that return address? R14 will save that return address. It means program before terminating and going to some other location, the processor stores the return address of that in R14. That's what the registers which are mentioned here plays a very important role. They makes the processor to operate in a phenomenal way. It means control and internal operations are taken care by the special purpose register and program status registers. That's it. Now, when I say what is the normal operation of the processor, then immediately you should say that it is a user mode. So it means that the processor can be in several modes. Let's see now how a current program status register looks like. You said two program status registers are there. Current program status register and saved program status register. Saved program status register, how it will be used, we'll see. But currently, the current program status register is most important. It is divided into four sections: flag section, status section, extension section, and control section. You should remember these sections and the names and the idea behind. You can observe status and extensions are almost shaded. You can observe one more point, that this is a 32-bit register, starts with the 0th bit. Left side you can see 0, 1, 2, 3, 4, 5, 6, 7, then all are shaded, then 28, 29, 30, 31. Observe, two important things are visible and two important things are not. Status and extensions are not visible, and they are visible as per the program. We will see how, say, the processor is working. The processor working completely depends on the bits of this program status register. Please remember, the processor working principle is completely depends on the current program status register, which is the most important register in the ARM processor. Similarly, in other processor, there will be a special registers like this only, which takes care of the control and internal operations of that processor. Here CPSR, in some other processor, some other register name might be there. Please remember, the whole operation depends on this register. It divided into four sections of 8 bits each. You can see 8 bits for control, 8 bits for extension, 8 bits for status, 8 bits for flags. So when I say four sections, you remember two sections are very important: flag section and control section. What do you mean by control section? Control section says that 0 to 4 bits are assigned for processor mode. In which mode the processor is operating? The processor can operate in total 6 modes of operation. Why 6 modes, you may ask? The question, for this question, the answer is very simple, saying that the processor can be in a perfect manner, which is called as system mode. It can be perfectly in a system mode. It means that it is taking care of all the internal operations and the control very much clearly, called as system mode. Sometimes the system might not work. Then that mode is called as abort mode. The system can be in abort mode. Sometimes the system is working perfectly when it is in system mode or user mode. Sometimes it is called as user mode. When it is user mode or system mode working properly, the processor may suddenly interrupted by somebody. What type of interrupt can happen? So it may be the processor in interrupt request mode. The processor may be in fast interrupt request mode. Sometimes the processor will be taken care by the internal activities in detail and want to change the operation by setting the values inside the current program status register. That can happen if it is in particular mode, which is called as supervisor mode. You know sometimes, so can you give me the super user ID? It asks super user. Supervisor mode, when it is in supervisor mode, it has full control. So when it can be supervisor mode, so it means if I put the values inside this mode from 0 to 4, then that decides in which mode it is. For example, one example, 10011, if I type, 10011. 10 all zeros. So it means, 0 to 4 means 5 bits. 5 bits means 32. In a digital conversion, 32. 10000 means 1 followed by 40 means 32. 1 followed by 2 zeros and 2 ones. Then it is 2 plus 1, 3. So 33. So I can put a digital value or hexadecimal value. You can call it as 32, 33, 35. So depending on those values which are fixed values, we will say that we are in that mode. It means the processor is in that mode. If it is in that mode, which are all the registers available for program purpose or operation purpose or decided by these bits only in the current program. Okay, so either the mode can be privileged mode or non-privileged. Privileged mode means I can easily access each and every bit in the program status register. I can read and I can write in the program status register easily. That is called as privileged mode. Non-privileged mode means I can read, but some of the fields, I'll call them as fields. Okay, some of the fields I cannot write, I cannot change. It means I don't have access to it. Such a mode is called as non-privileged mode. Please remember. So it means that the user mode, what I mentioned, is the first mode, is a non-privileged mode. I can read everything, I can access everything. Only few things I cannot access with respect to the control flags. Then control flags or conditional flags. Then that mode is called as non-privileged mode. User mode is a non-privileged mode. Remaining modes like abort mode, interrupt request mode, fast interrupt request mode, supervisor mode, or system mode or user mode, one and the same. Supervisor mode or undefined mode, all these modes are called as privileged modes. Privileged modes, I can easily change the required bits in the control as well as flag section easily. So there are interrupt masks. Before that, there is a fifth bit. You can see T. That is called as state. State of the processor, if I make it as 1, it means that thumb state is enabled. Sorry, what is that? Yes, thumb state is enabled. If I make it 0, arm state is enabled. What is the meaning? State and arm state. Thumb state means thumb instructions are enabled. The processor, in whatever mode it may be, if thumb state is enabled, it will use thumb instructions only. The processor understands only thumb instruction and respective registers are used in the instruction. So respective task is achieved. Thumb instruction means I clearly said it is a 16-bit instruction. That's what ARM processor has two instruction set, thumb instruction set and ARM instruction set. If T is equal to 0, it will be in ARM instruction set state, ARM state you can call it as, or it will be in thumb state. I and F are interrupt masks which are there to disable the interrupt request. Always when the processor is running the program, if any interrupt comes, if I'm able to disable those interrupts, then I can continue with the program without any problem. Discontinuity won't happen. So interrupt masking can be done with the bits called as 6 and 7 bits. They named as I and F. I is called as interrupt request disabler. F is fast interrupt request disabler. So interrupt requests are of two types: interrupt request, fast interrupt request. Interrupt request is disabled by interrupt mask. Okay, and F is what? Which is the fast interrupt disabler. That's how it goes. So status and extension are not used, and the remaining flags, the flags are the conditional flags, which we refer them as NZCV. After the operation, Based on the conditions of these flags, the processor decides what to do next. So N is for sign flag, Z or G is for zero flag, checking the zero flag, C is for checking the carry flag, V is for overflow flag. What the value it can have, either 0 or 1. If it is 1, the value says that it is set. If it is 0, it is reset. It means that if there is a sign change, then it is set. If there is a zero flag, then it is set. If there is a carry, then carry flag is set. If there is a overflow, then overflow flag is set. So conditional flags are set according to the operation which are performed, which will be reflected in CPSR register. Always the processor looks into the CPSR register. This is the explanation of CPSR register. In the next class, we'll stop here. In the next class, we will discuss on the remaining part, which is the register bank. When I am in different mode, how we'll make use of register bank, and we'll look into the remaining part in the next class. We'll stop here.